Okay, in continuing on in working with matrices and eigenvalues and eigenvectors, again, from the portion we looked into regarding the characteristic equation, again, I had mentioned never use echelon form of a matrix if you're determining eigenvalues. However, you may use echelon form for evaluating determinants, and we have had various forms or methods of looking at the value of determinants. And for this particular chapter that we have, including eigenvalues and eigenvectors, we have for a given matrix A, okay, you can determine the value of the determinant, okay, by this formula where the determinant of A is equal to, where we have -1 raised to the R, where R is going to be in reference to the number of row changes. And so you have -1 to the number of row changes power times the product of the pivots in U whenever A is invertible, and the determinant of A is equal to 0 whenever the matrix A is not invertible. And now, when we looked at, say, the matrix A, where we had 1, 2, 0, 0, 3, 6, -1, -1, 0, and let's say that if I put this in terms of echelon form, and okay, so we have just sort of looking in, so putting what we have in echelon form. So I want the first column to be not 1, 2, 0, but 1, 0, 0. Okay, so we have the first pivot position, okay, or pivot value is going to be at 1. And to make the adjustments, I'm going to take the second row elements, deduct twice the top row elements. So the middle row becomes 0, 3, and 1. And for the echelon form, okay, so I have 2 zeros at the middle row and bottom row of the first column. And to triangulate, okay, I want to transform this 6 into a 0. And to do this, okay, we have the next pivot value to be at 3. And if I make this 6 into a 0, so I'm going to take R of 3 minus 2 times the second row. In this case, have 0 minus 2 times 0. 6 minus 2 times 3 is going to be at 0. 0 minus 2 times 1 becomes -2. So we have triangulation of zeros and the pivots in U. And again, U is going to represent the echelon form of the original matrix, and the pivots we have at 1, 3, and -2. And we do not apply any row replacements. Okay, so number of row replacements R is equal to 0. So we have for the value of the determinant of this matrix, so we have -1 to the R becomes -1 to the 0, and any non-zero number to the 0 power becomes 1. And for the product of the pivots, we have 1 times 3 times -2, which would be -6. 1 times -6 is equal to -6. So that would be the value of the determinant. And let's say if I work this original matrix out a little differently, where we have applying row replacement. So if I had 1, 2, 0, 0, 3, 6, -1, -1, 0, and let's say that if I switched, okay, the second and third rows, okay, so I have 0, 6, 0 in the middle, 2, 3, -1 at the bottom. And again, so starting out after the row replacement, okay, I want the 2 to become a 0. So we have, again, taking the third row and deducting twice the first row elements. Bottom row becomes 0, 3, and 1. And where I had earlier transformed the 6 into a 0, it is now 3 that's going to be changed over to 0. So I need to take away 1/2 of 6. So we have, in this particular case, all right, so we have, just to modify, so we have R of 3 minus 1/2 of the second row. And just to kind of clean that up a bit, so you have R of 3 minus, okay, well, it's going to be 1/2 of the second row. So you have 0 minus 1/2 is 0, 0. 3 minus 1/2 of 6 is going to be 0. 1 minus 1/2 of 0 becomes 1. And this particular formation is going to be that reduced form where we have in the echelon form we have this to be our other matrix U, and this time we had the pivots to be at 1, 6, and 1. Now again, from earlier, okay, there was one row replacement in the progression. Okay, so there's one row replacement. Now for the value of the determinant of A, so you have -1 to the R representing the number of row replacements, which was once you have -1 to the first becomes -1. And for the product of the pivots, you have 1 times 6 times 1 is 6, and -1 times 6 comes out to -6. So again, through that approach, we still come out to the same determinant value. Now, again, so if A is a triangular matrix, then the determinant of A is the product of the entries on the main diagonal of A. This is an additional property. And say if we're looking at finding the determinant of A, and we already have A as a triangular matrix with the zeros laid out as they are, and the determinant of this again will be the product of the entries on the main diagonal. So we have for the main diagonal, we have upper left to the lower right in this case. So the values in the main diagonal, we have 1, 3, -2, and 5. So looking at taking the product, that is going to be the determinant of the whole matrix. So in this case, we end up at -30. Right. Now, now for what we have for this same matrix, and kind of going back to what we worked with in the case of eigenvalues and eigenvectors. Now let's say that with this same matrix, if I were to determine the eigenvalues of this particular matrix, okay, so what we're going to have in this particular case, all right, is that for, again, we have A minus lambda I quantity times x is equal to 0. And for A minus lambda I, so we're going to have running diagonally. Okay, so we have 1 minus lambda, 3 minus lambda, -2 minus lambda, 5 minus lambda. And for what we have in this case, all right, there is a rule of thumb here, and that is we have A minus lambda I is triangular, and the determinants will be the product of the entries on the main diagonal. Okay, so we have, once again, for the main diagonal, we have 1 minus lambda, 3 minus lambda, -2 minus lambda, 5 minus lambda. And taking the products, and you can leave in factored form and setting the determinant. Again, the determinant will be the product of the entries along the main diagonal. And in terms of what we have with the characteristic equation, you have the factored form and also in the expanded form. Okay, so quite a few terms here. Have lambda to the 4th minus 7 times lambda cubed plus 5 times lambda squared plus 31 lambda minus 30 is equal to 0. And from this, the factored form or the expanded form, we're going to have with the eigenvalues, those will be 1, 3, -2, and 5.